Let's talk about limits at infinity. What is the limit as x approaches infinity of 1 over x? What's the answer? Well, let's start plugging in large numbers. Whenever the denominator is large, you're going to get a small value. If the denominator has a small value, you get a large value. So for example, 1 divided by 10 is 0.1. 1 divided by 100 is 0.01. And 1 divided by 1,000 is 0.001. Therefore, we could say that 1 over infinity, which is a very, very large number, is going to be about 0. So the limit as x approaches infinity of 1 over x is therefore equal to 0. Now what about the limit as x approaches negative infinity of 1 over x? 1 divided by negative infinity will still be 0. If you divide 1 by negative 0.1, by negative 10 rather, this would be negative 0.1. If you divide 1 by negative 100, you get negative 0.001. Negative 0.01. And if you divide it by negative 1,000, you get negative 0.001. It's still approaching 0 just from the left side. So this is 0 from the right side, this is equal to 0 from the left side, which you could just say it's equal to 0. Now, let's graph this function. The graph of 1 over x looks like this. It has a vertical asymptote at x equals 0, and it has a horizontal asymptote at y equals 0. So as you can see, as x approaches positive infinity, you're going to get the horizontal asymptote, which is y is equal to 0. As we follow the curve all the way to the right, it's going to get closer and closer to 0. This will also give you the horizontal asymptote on the left side, which is also y equals 0. To get the vertical asymptote, as x approaches 0 from the right side, this will give us positive infinity. So that tells you that 0 is the vertical asymptote. If you approach 0 from the left side, you're going to get negative infinity. It's going down. So the x value that leads to a y value of infinity, that's going to be the vertical asymptote. When x approaches infinity, the y value corresponds to the horizontal asymptote. Let's try another problem. What is the limit as x approaches infinity of 1 over x squared? Well, here we have another bottom-heavy function. And if we plug in a large number, let's say like 100, 100 squared is 10,000, and 1 divided by 10,000 is still a very small number, 0.0001. So we could say this is going to approach 0. Anytime you have 1 divided by infinity, it's always going to equal 0. So here's a general theorem. The limit as x approaches infinity of some function 1 over x to the r will always be equal to 0. So that's something that you may want to keep in mind. What is the limit as x approaches infinity of 8 divided by 3x plus 4? So what process can we use to figure this out? What we need to do is multiply the top and the bottom by 1 over x. And so this is going to be equal to 8 divided by x. And then on the bottom, we're going to distribute. 3x times 1 over x is 3. And 4 times 1 over x is 4 over x. So now we can apply the limit as x approaches infinity for every term in this fraction. So recall, anytime you have, let's say, a fraction like 1 over x, that's going to turn into 0. The limit as x approaches infinity for 1 over x is 0. So we can rewrite this as the limit. Well, this is going to be, let's separate the 8 from 1 over x. So it's 8 times the limit as x approaches infinity, 1 over x, over 3 plus 4 times the limit as x approaches infinity, 1 over x, if you want to show every step. So we know this portion is equal to 0, and the same is true for this part. So it's going to be 8 times 0 divided by 3 plus 4 times 0. So this is 0 over 3 plus 0, which is 0 over 3. Basically, the whole thing is 0. So anytime the function is bottom heavy, notice that the degree of the denominator is greater than that of the numerator. Anytime it's bottom heavy, it's going to equal 0. Now let's work on something else. What is the limit as x approaches infinity of 8x minus 5 divided by 2x plus 3? So what is the answer in this case? Now notice that the degree of the numerator is the same as that of the denominator. They're both to the first power, so they're in the first degree. Whenever the degree of the numerator and the denominator is the same, you can simply divide the coefficients. So 8 divided by 2 is 4. Therefore, this is going to equal 4. Now let's prove it. Let's show our work. So I'm going to multiply the top and the bottom by 1 over x. So therefore, this is going to be the limit as x approaches infinity. 8x times 1 over x is simply 8. And then we're going to have 5 times 1 over x, which is 5 over x. And then this is going to be 2 plus 3 over x. The limit as x approaches infinity of 5 over x is going to equal 0. If you want to write it out separately, you can write it out as 5 times the limit as x approaches infinity of 1 over x. So that's 5 times 0, which in the end is going to be 0. Now 3 over x, that's also going to change into 0. So 8 divided by 2 is 4. So keep in mind, for those of you who want to write out every step, you can write it like this if you want to. And then you can apply the formula. Since this is a rational function, it's going to equal 0. But in the end, you're going to get the same answer, positive 4. What is the limit as x approaches infinity of 5 minus 7x cubed divided by 3x plus 5x cubed plus 9? Go ahead and try this problem. So notice that the degree of the numerator is 3, and the degree of the denominator is 3. That's the highest exponent on top and on the bottom. So you could say that as x becomes large, 5 is insignificant to 7x cubed. Because if you plug in 1,000 into x, 1,000 to the third is 1 billion times 7, that's 7 billion. 5 is insignificant to that. So 3x and 9 are insignificant to 5x cubed. So this is approximately equal to negative 7x cubed divided by 5x cubed, which the answer turns out to be negative 7 over 5. But let's confirm it. So what we need to do is multiply the top and the bottom, this time by 1 over x cubed, since the highest degree is x cubed, or 3. So this is going to be the limit as x approaches infinity, 5 over x cubed minus 7 divided by 3 over x squared plus 5 plus 9 over x cubed. 5 divided by infinity to the third power is going to be 0. Anytime you have infinity in the bottom of a fraction, it's 0. So we're going to have 0 minus 7. 3 over infinity squared, that's going to be 0, plus 5, plus 9 over infinity cubed, which is 0. So in the end, you get negative 7 divided by 5. What is the limit as x approaches infinity of the square root of 16x squared minus 8 divided by 2x minus 5? Go ahead and try it. So when x is very large, only the most significant term will remain, or will be important. 8 is insignificant and 5 is insignificant. So this expression becomes equal to the square root of 16x squared divided by 2x. The square root of 16 is 4, and the square root of x squared is x. And 4x divided by 2x is 2. So that's going to be the answer. But now let's confirm it with a step-by-step process. So we're going to multiply the top and the bottom by 1 over x. So on the bottom, 2x times 1 over x is simply 2. And then we're going to have 5 over x. Now how do we put the 1 over x inside a square root? So let's say if you have x root 2, and you want to move the x into the square root, you need to multiply the exponent by 2. So it's going to turn into 2x squared, because the square root of x squared is x. So if you want to move it back in, you need to double the exponent. So to move in 1 over x into the radical, we'll need to multiply the inside by 1 over x squared. (16x squared) times 1 over x squared, that's going to be just 16. And then we're going to have 8 over x squared divided by 2 minus 5 over x. So now let's apply the limit as x approaches infinity to every term. It's not going to affect the 16 because that's a constant. 8 over x squared, that's going to turn into 0. And 5 over x, that's going to be 0 as well. The square root of 16 is 4. So 4 divided by 2 is 2. And that's going to be the answer. Now let's try this one. What is the limit as x approaches infinity of the square root of 9x to the 6 minus x squared divided by 3x to the third plus 1? So we know that these terms are insignificant. So this becomes equal to the square root of 9x to the 6 over 3x cubed. The square root of 9 is 3. The square root of x to the 6 is 3x to the third. So these two cancel. The final answer is 1. Now to show your work, we can multiply the top and the bottom by 1 over x cubed. So this becomes the limit as x approaches infinity. And then on the inside, we're going to have 1 over x cubed, actually x to the 6 now. The exponent will double once we move it to the inside. So 1 over x to the 6 times 9x to the 6 minus x squared divided by 3 plus 1 divided by x cubed. So now what we're going to do is rewrite this expression. So this is going to be equal to the square root of 9 plus the limit as x approaches infinity, and that's going to be negative 1 over x to the 4th. That's negative x squared divided by x to the 6. And then on the bottom, we're going to have 3 plus the limit as x approaches infinity, 1 over x cubed. So this is going to become the square root of 9, and the limit as x approaches infinity for 1 over x to the 4th, that's going to be 0. And for 1 over x cubed, that's going to be 0. And then the square root of 9 is 3. So 3 divided by 3 is 1. What is the limit as x approaches infinity of this function, the square root of 9x squared plus x minus 3x? What do we need to do here? What should we do? Well, if you're not sure what to do, use direct substitution. Plug in a very large number into the function. So let's use 1,000. So 9 times 1,000 squared plus 1,000 minus 3 times 1,000. Now if you type this whole thing in, you should get 0.1666620,373, which is basically 1 over 6, which is 0.16 repeating. So 1 over 6 is the exact answer. But now, what techniques can we use to actually get that answer? The first thing you should do is write this as a fraction, put it over 1, and then multiply the top and the bottom by the conjugate. That is 9x squared plus x plus 3x. So when we FOIL the binomials on top, the two middle terms will cancel. So what we're going to have is the limit as x approaches infinity of 9x squared plus x, the square roots cancel, and then 3x times 3x is 9x squared, but that's going to be negative 9x squared, divided by what we have here. These two add up to 9, so we can get rid of it. So based on what remains, we're going to multiply the top and the bottom by 1 over x. So this is going to be the limit as x approaches infinity. X times 1 over x is 1. Now, inside the radical, we need to multiply it by 1 over x squared. 9x squared times 1 over x squared is going to be 9. X times 1 over x squared is going to be 1 over x. And 3x times 1 over x is just 3. So now all we need to do, is apply the limit to 1 over x. The limit as x approaches infinity of 1 over x is 0. So this is going to be 1 divided by the square root of 9 plus 0 plus 3. And we know the square root of 9 is 3. And 3 plus 3 is 6. So the final answer, as we mentioned before, is 1 over 6. What is the limit as x approaches infinity of the function arctangent of x? So what is the arctan of infinity? Well, let's plug in points. So first put your calculator in degree mode. So if we plug in arctan of 100, this is 89.4. Now if we plug in arctan of 1,000, this is 89.94. Notice that it gets closer and closer to 90. So this is equal to 90 degrees, or in radians, pi over 2. If you recall, the limit as tangent, or as x approaches pi over 2 from the left side of tangent x, that's equal to infinity. So when dealing with inverse tangent, you need to switch these two values. Now what is the limit as x approaches negative infinity of the arctangent function? So if we plug in arctan of negative 1,000 while it's in degree mode, this is going to be negative 89.9. So this is negative pi over 2, or basically negative 90. Tangent is negative in quadrants 2 and 4, but arctan only exists in quadrants 1 and 4. So that's why we got the answer that's in quadrant 4, negative 89.9, which gets it very close to negative 90 or negative pi over 2. So make sure you know these values. Now there's one more that we need to go over. What is the limit as x approaches infinity of e to the negative x? What is the answer? So if we plug in infinity, this is going to be e to negative infinity, which is 1 over e to the infinity. E to the infinity is infinity, and 1 divided by infinity is 0. So as x approaches infinity for this graph, it's going to be 0. So even if we have this one too, the limit as x approaches negative infinity for e to the positive x, this would be e to negative infinity, which is basically 1 over infinity. That too is 0. If you were to graph e to the x, it looks like this. Notice that it has a horizontal asymptote of y equals 0. So as x approaches negative infinity, that means if we follow the curve all the way to the left, the y value becomes 0.